In this video, we will advance our thinking on finding unknown angles given parallel lines and a transversal. This is what we discovered earlier, and let's leave this here as a reference. We have this example here where we have two parallel lines and a transversal, and we are given that this is 125 degrees and we have to figure out how much is this angle. So before we get started, let's just number our angles. So this is 1, 2, 3, 4, 5, 6, 7, 8. And then let's start discovering some relationships. So 1 and 4 are supplementary angles because they are along this line L3. So angle 1 and angle 4 are supplementary, which means measure angle 4 must be equal to 180 minus 125. So that is 180 degrees minus 125 degrees. So that is 55 degrees. So now we know angle 4 is 55 degrees. Now let's look at angle 5, which is what we want to find out. According to Euclid's fifth postulate, the same side interior angles add up to 180 degrees. In this case, angle 4 and angle 5 are on the same side of the transversal and they are interior angles. So they are the same side interior angles and they must add up to 180 degrees. So let's write that down here. Measure angle 4 plus measure angle 5 equals 180 degrees because of Euclid's fifth postulate. Now, of course, I could have also written that angle 4 and angle 5 are supplementary. So, since angle 4 and angle 5 together add up to 180 degrees, we can easily find measure angle 5. Measure angle 5 must be equal to 180 degrees minus 55 degrees, which is equal to 125 degrees. So this angle, so A is equal to 125 degrees. Now that should not come as a surprise because even if you look at them, they look pretty much like each other. But in geometry, we don't go by how it looks. We have to prove what it is by giving our reasoning. Now, angle 1 and angle 5 are called corresponding angles. If we kind of slide down line 1 towards line 2, angle 1 and angle 5 will have the same position. So these two are called corresponding angles. And corresponding angles are congruent to each other. Now let's look at another example. Again, we have two parallel lines and a transversal, and we are given that this is 95 degrees and we have to figure out how much B is. So before we get started, let's just number our angles. So let's call this 1, 2, 3, and 4, and then 5, 6, 7, and 8. Now let's see what we can do. We know that angle 3 and angle 4 are supplementary angles because together they are along this line. So angle 3 and angle 4 are supplementary angles. So measure angle 3 must be equal to 180 minus 95. So 180 degrees minus 95 degrees, that is 85 degrees. So now let's look at the relationship between angle 3 and angle 6. Again, because of Euclid's fifth postulate, we know that angle 3 and angle 6 need to add up to 180 degrees. So measure angle 3 plus measure angle 6 equals 180 degrees because of Euclid's fifth. We have to find out a shorter way to write this. So because of Euclid's fifth postulate. So if we know that angle 3 is 85 degrees, let's just write that down here. Angle 3 is 85 degrees, so measure angle 6 must be 180 degrees minus 85 degrees, so it is 95 degrees. So B is equal to 95. Now these two angles here, 4 and 6, this angle here and this angle here, they are called alternate interior angles. Alternate because they are on alternate sides of the transversal, and interior because they are on the inside. So alternate interior angles are congruent to each other. You don't have to remember all this because you can always prove it using a combination of supplementary angles, vertical angles, and Euclid's fifth postulate. Let's look at one last example. So we have two parallel lines and a transversal, and we are given that this angle is 88 degrees, and we want to find out how much this is. So again, let's start numbering the angles. So 1, 2, 3, 4. Make sure when you're numbering the angles that you're going in a circle like this. So 5, 6, 7 and 8. So now let's see, we are here and we want to reach all the way here. There are various ways we could do it. Let's think of one way. So we know that, let's look at the relationship between angle 2 and angle 4. Angle 2 and angle 4 are opposite angles or vertical angles. So measure angle 4 must also be 88 degrees. So let's write that down here. Angle 2 is congruent to angle 4 because angle 2 and angle 4 are vertical angles. So measure angle 4 is also 88 degrees. Now let's see, okay, let's write this here. Measure angle 4 is 88 degrees. Now we know the relationship between angle 4 and angle 5. They are supplementary angles because of Euclid's fifth postulate. So they must add up to 180 degrees. So let's write that down. Measure angle 4 plus measure angle 5 equals 180 degrees because of Euclid's fifth postulate. So we can easily figure out measure angle 5 because that is just 180 degrees minus 88 degrees, and that is equal to 92 degrees. So C must be equal to 92. Essentially, we can go from any one angle amongst these 8 angles to reach any of the other angles, basically by using a combination of supplementary angles, vertical angles, and Euclid's fifth postulate.